Hi, everyone, and welcome to this webinar with the DevOps Institute Continuous Learning Community. Today, we're happy to have DJ Schleen, who is a security architect and DevSecOps evangelist. He's a really big thought leader in the DevSecOps space specifically. He works in the healthcare industry, and he's a good friend of the DevOps Institute. So, DJ, welcome, and we're so happy to have you.
Well, thank you, Taylor. It's great to be here today. So what I'm going to present is a conversational deck called DevSecOps is the correct way to spell DevOps. And for me, that's one of the terms that I use quite regularly, especially when I'm talking online. I sort of find it funny because I'm not really a big fan of the word DevSecOps. I had talked to John Willis about a year and a half ago, and he was saying to me that DevSecOps is a word you can't get behind. Like, it's just something that's doesn't make sense in the world of DevOps. And so I explained to him that if you add security or sec at the beginning of this term, then you're leading with security. And if you add sec at the end, so DevOps sec, you're trailing with security, or your security is following you, and it's an afterthought like it always has been. So security in the middle of everything, really it should be just part of what you do day to day. Security should just be part of the development and operations and just the way software is developed. So let's get into this a little bit. So I'm going to talk about three pillars, the core of DevSecOps. And the first one I love to talk about is culture. DevSecOps is nothing without the people that implement the processes and define the techniques and that are really focused on working together and building the software. So a culture just can't be forced. Culture has to be organically grown. And leadership today has a challenge. For example, we had some of the executive team at a company that I work with that says, how do we instill culture? How do we create culture? And at the end of the day, you can't have culture drilled down from the executive level. You have to come up with something that you're basically the guardrails on the highway of culture. So you have to foster this, and you have to ensure that people have the tools to communicate and talk with each other, and the flexibility to make decisions on their own and help create software a lot quicker. The second part of the three pillars is technique, and this is the way you do things. Again, people define the processes and the way that software is developed, and each organization has a different technique or a different way of building software, and that's where DevSecOps and DevOps are very malleable. It's very fluid from organization to organization. The idea is that you're building software and you have a software development pipeline defined that suits the way your business works. So that's all the way from the idea of a product feature all the way to the point where it's delivered into production. So the technique and the way that you do things and the way you check code in, the way the business interacts with developers is extremely important to DevSecOps. And the third pillar is tools. And tools always comes last, because you can have any kind of tool. And at the end of the day, they say a fool with a tool is really just a fool. And that resonates with me. It's something that you want to ensure you have the appropriate tools, but tools need to follow what your processes are. They have to fulfill the use cases that you have as a business. If you just use a tool because it's the shiniest new thing, it's not going to be as effective as really understanding that this tool can help you fulfill a business need or some kind of development need. So what about security? Again, security comes into all of this, and DevSecOps itself, it really defines and requires top software development talent and the right tools, right techniques, and the right KPIs. When you have all of these defined and you add security into this mix, it should just be part of the overall conversation that people are having as they develop software and push it through into production. And security should be everywhere. It should be right from the requirements gathering and the use cases that you define, all the way to operations and how things are deployed out into the production consumer-based consumption environment. So you have to remember that once software is delivered to production, a lot of times it's forgotten about and it just stagnates out. People keep using it, and vulnerabilities and security issues happen on a daily basis. There's a new exploit that comes out all the time. So monitoring things and looking at your applications in production is very, very important, because you want to make sure that you're constantly scanning, you're constantly looking at your security posture, and you're constantly measuring it. So we'll dig into a little bit of the importance of DevOps. It's not just a movement, it's really happening today in a lot of businesses. In some of the largest companies, the Fortune 50 companies, are adopting DevSecOps and really changing the conversation. A lot of these initiatives started as DevOps implementations and rollout, where the executives and the business leaders and the stakeholders of an organization say, we want to adopt DevOps. We hear that this is a fantastic idea. And as a security organization, we tried to, and we actually succeeded at, changing the conversation and changing the term that we use across our enterprise to DevSecOps, because it defines the fact that we have to be more secure. We have to protect people's PHI, PII, and all the information that they trust us with on a daily basis. So some of the excuses of DevOps and DevSecOps is, it's too difficult. I've heard this term way too often. And this is spoken by traditional security analysts about working with developers. It's traditionally been like oil and water, where security has been this culture of no. A developer says, hey, I'd like to use this technology. Maybe it's something that the security team doesn't understand, and usually that's because there's not a lot of technical security engineers in the industry. But when we start thinking a little bit about having security engineers learn more about development and sit down beside someone and really explain what the security implications of the software a developer implements is, that's where you start building this culture of trust. Another thing I hear is it's extremely slow, and this is going to be your developer and your system reliability engineer waiting for the security scanning to complete. So this is where we really have to, as a security organization, be cognizant of how long our tools take to execute and how we integrate those tools into our business process so we don't interrupt the flow of software going through our pipelines. Another excuse is, but we just adopted Agile. And this is something that I've heard quite often, where organizations move from waterfall, especially some of the traditional large organizations, they move from waterfall to Agile, scaled Agile framework as well. And the idea in the industry, or some of the preconceived notions that are out there, are that Agile and DevOps sort of counteract each other, and are like oil and water as well. And that's not necessarily true. We have the same processes in Agile. The Scaled Agile Framework 4.5 came out, and it actually includes a section on DevOps and integrating DevOps into this Agile workflow. One of the problems with that specification and that the Scaled Agile Framework 4.5 is it doesn't talk about security and DevOps, and hopefully that comes out. But this just adopted Agile, that's going to be spoken by your product owner and the PMOs, and that's their reaction to moving to DevOps. And I think that just needs to be explained. I look at Agile, like product owners and development, as almost two separate tracks. If you're pushing your code base to production when you create a feature, so a feature's done and it goes through the pipeline, it goes right out to production, Agile iterations and releases just become stakes in the sand almost. So, if you look at the traditional release cycle of iterations, you're looking at 6 potential iterations of 2 weeks. So you have 12 weeks before you're releasing software to your production environment and your customers, and that's just way too long. There's going to be things that happen to that code base. You're going to have so many changes. You're going to have integration issues. And if you can react quickly to things that happen in your production environment, that's actually a security benefit. Because if you have a vulnerability that gets released, a 0-day, you can look at implementing a fix and pushing this out right away. And this is something we used to do 30 years ago, where we were developing software and we were just pushing it directly to production. Now, at that time, we didn't have these gates and these tool sets to look for security vulnerabilities and do automated acceptance testing and that kind of thing. But now today, we have this infrastructure and this support that helps us do the same kind of things that we were doing, and with a modern twist on it and more control. So the other and the last complaint that we've seen is we have no budget for that, and that's the CISO telling a development team that we don't have budget to adopt this. And really, again, this comes back to culture and process. Chances are you have all the tools to do this, and you're DevSecOps. You might have to add some security tools. But at the end of the day, the CEO or the leadership is responsible. If you don't have a CISO, they're basically liable for any security issues or security vulnerabilities that happen to their applications when they're running in the production environment. So having no budget, again, it's not about cost. It's not about implementing a huge system. This is just the developers working together and doing the exact same thing that they have been doing, but having more flexibility, automation involved there, and a lot of process defined. And that's something that we've never had before. We've always talked about defining process, but we would use a documentation to define it. The process is really the code that you create. This is where infrastructure as code comes from. This is where security as code comes from. When you say that we have no budget for that, really we do. What we're doing with DevSecOps is we're just taking control over a process and ensuring that quality, no matter if that's product quality or security quality, goes up. And if that goes up, you have less time that you need to remediate issues, or less issues to remediate. So this is an interesting quote. It's like developers say, what? We'll have more time to spend in Colorado? And that's absolutely true. This comes back to the almost office space analogy, where developers don't want to come in on Sundays. And when I say developer, I'm talking security engineers, I'm talking site reliability engineers, the business. That's everybody. People don't want to come in on Saturday or Sunday to remediate something. And if they need to, they want to do it quickly and get back to their day. I live in Colorado, so I get a chance to mountain bike on Green Mountain. And if I can push to production from Green Mountain, which is something that I've done before, it's great. I can get back to what I'm doing. It's a less impact and less interruption, no matter if it's on a weekend or during the day. When you have less interruption, people can focus on delivering and focus on the quality and the security of the products that they're doing. So the proof is in the numbers, right? I mentioned less time. So you have less time on unplanned work and more time on new work. And these, I think, are very conservative numbers. I've seen situations where it's 70% of your time in an organization or developer's time is remediating issues, vulnerabilities, bugs, and that kind of thing. And that means 30%, or in this case, 21% of your time is on new features. And that's just not acceptable from a business perspective. If you're spending most of your time remediating issues, your business is going to suffer because you're not getting features out to your consumers and fulfilling the needs of the business. So some of the other things about DevSecOps and the numbers is that you have a 46-time multiplier and improvement in deployment frequency. So you can deploy a lot quicker than you can if you're not using DevSecOps or DevOps. You have a 440 times faster lead time for changes. So you can get changes out to production and in a quicker method, quicker way, and that information flows to the developer a lot quicker. And then, faster mean time to recover and lower change failure rate. You're fifth as likely to have a change failure, and that's very important. So this is an indicator of your quality going up. And we can't afford not to do this. This is something that we've been talking about for years: the reliability of software, the scalability of software, the security of software, defining our processes, understanding how software gets imagined to how it's delivered. That whole process, it's really application lifecycle management. It's everything involved to create this new revolution and movement that we call DevOps and DevSecOps. So we're going to dig a little bit deep into 4 technologies and 4 different purposes. So these are the tools that, if you're going to start off with a DevSecOps program, these are the 4 mandatory controls, mandatory things that you need in order to deliver a DevSecOps program in your organization. So without further ado, we have static analysis and security testing. This is the first thing that you most likely want to implement. And what this is, the acronym is SAST, and this is going to be an inside look at the code that you're creating or your developers are building. So this is looking for things like SQL injection, cross-site scripting, any kind of parameterized SQL, or things like that that could cause a security vulnerability, or it could be just the way you program something. If it goes through the function chain or the execution chain, it eventually turns into a vulnerability. So this is analysis that gives us some indicator of the code and the quality of the code from a security perspective. The second tool set we want to use is open source software management, and it's almost not even the second tool. One of the biggest problems in software development is open source software. This software is sitting out, it's public, in the public. The attackers know about this software just as much as you do. And one of the problems, I see with this is developers will go to Stack Overflow, for example, and I'm not, pinpointing that site in general, but developers will Google and say, how do I do this? And they'll take some code snippet and they'll put it in your code base. Who knows where that code snippet has come from? It could be from a commercial application that's licensed and or open source license that instantly open sources your whole software base. So this is components that are coming in as well as the licenses associated with that. And so again, this is your application is that gray circle. This is things coming into your application from the outside. The third control you want to have is dynamic analysis and security testing. Now, this is going to be the attacker's view of your application. So this is scanning your perimeter. It's scanning the servers that your applications are running on. It's looking at things like misconfiguration or security holes or even information disclosure. So a lot of times you see underneath a website, when it's giving you a response back, it has a lot of information about what server you're running, what, powered by IIS or powered by Apache or Tomcat or Nginx or anything. And then sometimes you even get internal IP disclosures, and hackers could take that information and use that to pivot. Basically, they're gathering as much reconnaissance as they can about your system, looking at how they can exploit it. The fourth thing, and this is a term that I sort of came up with because there was just nothing else to call it, this is container image vulnerability and security testing. Again, this is a DJism. And what this is if you are developing containers, and in most of the industries, most of the organizations ultimately want to get to a containerized infrastructure. And that's a whole other discussion from a security control perspective. But what this will do is actually look at the container itself and look at the applications, the binaries that are running in that container, and give you a manifest or a bill of materials. And that's something that we've never had before that's very important is an automated way to know every single library, every single piece of the underlying operating system, and if there's vulnerabilities in it. So this is almost like your virus scanning, of old, but this is looking at the container level, and this will let us know exactly where security vulnerabilities are in our organization and what we need to focus on if a 0 day comes up. So integrating technology, it's like putting a cat inside of a group of penguins. Sometimes it's extremely difficult to blend in and to do anything. So integrating technology, there's a bunch of different ways to do it. There's branching and merging strategies like GitHub flow or Git flow. This is an example of on merging. When you merge your code into your central code repository, you can do security scans there. Now, you don't want to do them all the time, but you definitely want to protect your golden code or your master branch, and that's just the code that's ultimately going to get to production. Daily scans are very, very much important. If you check some code in, or if code goes into a repository and it's sitting there, it could become stale, and security vulnerabilities could still apply to it. So if you check in some code and there's a library or dependency or web service that's used that gets deployed and hasn't been scanned for security vulnerabilities, that's a big gap. So that's something that we really want to do is scan everything regardless every day and make sure that there's no security vulnerabilities or any exploitable code in there. And then a lot of times we want to scan immediately. So this is going to be your IDE plugins for developers. So you're doing security scanning right inside of your GUI where you're developing code and it's telling you as you're typing that you're introducing a security vulnerability. So this is completely shifting left, and that's going to be a term you're going to hear a lot in DevOps and DevSecOps, but taking that information sooner and returning it to the developers and getting that information to them quickly. Now, there's a lot of issues that are still being worked out with these processes. For example, you talk about fail fast, fail often. Well, there's a point where you want to fail and a point where you don't. So, and that's just to keep the flow going. There's folks waiting for software to be deployed to a QA or a user acceptance environment. And if you're failing the build before it gets out there, then you are holding that resource up. So they can't do the acceptance testing, the feature testing. Now, if there's a vulnerability or something in there, it doesn't mean that you can't deploy it to your QA environment. What it means is you can't deploy that to production without having that issue remediated. And this example here is a full DevOps pipeline, and this has evolved over time. It started off very simply, and it basically talks about this whole process being application lifecycle management. Things that are in dark blue here are security interactions in the pipeline. So we want to start off with threat modeling, which is looking at the attack vectors of the software you're creating. And you do that even before you design or while you're designing the application. So if you don't know what you're protecting, you could be throwing the boat and the gamut at something, and it's never going to happen. So for example, thinking about PHI, and you don't use any PHI, so why protect for it? So that's just an example, but that's what you're doing with that threat modeling. Third-party components and SAST and open source software management, those are huge parts of the process you want to do sooner rather than later. And then image vulnerability scanning happens after things get packaged and ready to go. You can automate the testing, stage this, and you're also doing ethical hacking at the same time. There's things that you can automate. Automation isn't the only thing that you need to do. There's this manual interaction with ethical hacking. The idea of these tool sets is they're giving reconnaissance information and things that you can give to your ethical hacking team that gives them a head start. This again is some individual or some team that continues to work with the developers, helping them remediate these issues. And then when you deploy it to production, again, don't forget about it. Run container cycling or some chaos engineering. Keep doing your vulnerability analysis and looking at the hosts and making sure that those are updated and patched and ready to go. Basically, this whole process, the idea is traditionally this has taken a long time to do. We want to get to the point where we're doing this in minutes to hours, and we're gathering information constantly. We want to know how fast things get executed, and that we're not introducing any unnecessary blocks to any individual in the team. So we're collecting all this information and consolidating this. This is simply because a lot of these tools will find the same vulnerabilities or the same CVE, and we want to make sure that we're distilling the noise and we're taking the noise out of this. And if we fix the issue in one place and we track the issue in one work item or one incident, or one change or a problem for that matter, you're, again, reducing the noise. You're making it more palatable for the business to prioritize, because there's just not a lot of noise. So that's the static removal right there. And then from that consolidation, we can send this over to our product owners. We can send it to our SOC. We can send it to our data science team to have them do security modeling and predict different places that we have to focus on, or even correlate some of this information with physical security. There's a convergence there that's happening where physical events that happen worldwide sometimes are accompanied by a cyber attack or some sort of cyber threat. So consolidating that information and overlaying it on each other is a very important part of this. So this is where DevOps and things that we do have impact on other roles in the organization that really don't have anything to do with security or development. So we're going to look at measuring. We're going to talk a little bit about some KPIs and things that we need to look at. I've never measured a sandwich before, but this one looks pretty good at 2.5 inches, or centimeters for that matter. So key performance indicators. What we're doing with these things is we're taking metrics, and a metric is just a number. It has no action. It has, the relevance level of it is just a stake in the ground. It's just something that's there. So a KPI is something that's relevant, something that the business looks at and says, are we at a threshold? Are we, do we need some remediation here? Do we need to address these things? Are things performing as we had planned? And where do we need to focus attention on improving the process, reducing waste in the pipeline, and that kind of thing? So what we want to do with these KPIs is, first, we want to automate those. We want to collect the information from our systems, and then we want to disseminate it, and we want to get that to the appropriate individuals. So that usually is a data science team. It could be a stakeholder. It could be a dashboard. We want to get that information to the right people at the right time. And then we want to investigate it. So we want to look at this information, start making decisions, whether those are technical decisions or business decisions, and understand what this information coming from our systems is. And all of this is really about efficiency. If we can automate, disseminate, and investigate, and we can automate this collection, what we're doing here is we're getting away from Excel spreadsheets. And that's traditionally how organizations would track numbers. They would use an Excel spreadsheet, they create some graphs, they copy and paste. It was a very manual process, and again, that's waste. That's some task that can be automated, and that information can be gathered. So if we look at some KPIs, we talked a little bit about defect density, and defect density is one defect in 10,000 lines of code. So we're looking at a defect density of 1.0, and that's going to be a threshold. So anything above that is something that we need to address. We have too many vulnerabilities, and this could be security defect. This could be non-security related defects. Those are two different things that we can track, but from a security perspective, we want one defect at 10,000 lines of code. And we don't want that. We want it to be 0. But if we know where we are, we can get somewhere, and we can have our goals in the future, and we can start reducing these. Some of the aggressive side of this is changing this defect density to 0.006. If we do the math on that, that is very, very few vulnerabilities, and that's for every project that we create, every application, and that's across the enterprise, and that's a big stretch goal. especially when you do some baseline scans and you find a defect density of 98 or something very high. To get to this point requires a great amount of collaboration between your security team and your development team. It requires understanding of what these vulnerabilities are, what the impact is to the business, and sometimes these are just false positives. And sometimes one fix will change and get rid of 2,000 issues. So there's a wide range of remediation that can happen to get to this point. One of the things that I like to do is cap defects. So we'll do a baseline scan. We'll find out how many vulnerabilities are in that piece of software. And we'll tack a threshold and say, you can't do anything more than this. So for example, let's say you have 100 vulnerabilities and you're going to check your code into a repository. If you introduce issue number 101, the commit that goes in, or so the change that you want to put into that repository, is rejected. And the reason why we do that is so defect saturation or density goes down eventually, and you can't introduce more vulnerabilities. That's sort of stopping the bleeding. And then as issues are remediated, you keep automating and dropping that threshold. So if you keep doing that, and that's either a bug bash that you're doing, or you might have an improvement sprint where people look at vulnerabilities and just try to smash them out. If that happens and people check in less and less, eventually you get to defect 0.0. And I've seen a lot of teams do that. And they started off at defect density of 4 and they got to 0. And that is a huge thing for a team to get to. That means that there are no security vulnerabilities known at the time that we scanned it. So again, we're looking at this aggressive stretch goal for defect density. One of the other KPIs I like looking at is the percentage of security-related work items. So even though a work item is a work item, no matter if it's a defect, like a bug or something from a functional perspective or a security issue, we want to tag security issues and make sure that it's less than 15%. And that is just to make sure that we have our security under control and we have the defects under control in the organization and the software. Definitely looking at security build time delay. So less than 5 minutes execution is what I like to target. Developers expect scanning to happen immediately or very, very quickly. And especially if you're pushing this stuff and these code changes right into production or eventually into production and doing a lot of automation, this could be a big difference in that whole execution pipeline that you have. So I like looking at things that run less than 2 minutes. So a lot of open source software scanners will run pretty much instantly. If you look at static code analysis, if it's looking at the changes rather than the whole application, it's going to be pretty fast. The initial scan might be slow. And if you're looking at container vulnerability analysis, that's going to be very quick as well, and usually that's done constantly. And dynamic analysis is one of those slow things. Sometimes you can do that out of band, so not in your automated pipeline. And then sometimes you can get away with doing it in your pipeline if that application is very small. And that's going to happen at staging time. I want to look at security failed builds and security drag. So if we have a security vulnerability, again, one of the things that we can do is still stage that and still put that through to our QA environment so we don't hold up those teams. But we want to make sure that we know if any of those builds has failed because of a security vulnerability or an introduction of a security vulnerability, because that reduces the efficiency of your pipeline and introduces a security drag. So we're looking at less than 5% of builds that are failed because of a security or critical security vulnerability. And then we want to look at, again, the security defect escape rate and keep that less than 10%. And this is security defects that are found after something is put into production. So there's obviously some challenges to all of this. Some things definitely need time to change, especially when you have these organizations that are used to separating teams. That's going to be one of your biggest challenges. Some people call them silos. I usually call them kingdoms because, or fiefdoms, because you're going to have these organizational units that have their own budget. They have their own leadership, and having feature teams that are made up of multiple individuals from multiple backgrounds and skill sets. So for example, an iOS developer, a front-end developer, a back-end developer, QA, somebody to deploy this. A lot of these roles are part of different organizational units. And if you have a bunch of feature teams that are separated, that are doing their features, sometimes you lose that developer culture or that developer interaction between, for example, iOS developers. You might have two people sitting apart by 15 feet, and they never talk to each other or share information. So this is where you want to do meetings or guilds or some sort of brown bag to bring everyone together on the development technology team, and make sure that you're growing from an organization. Because it's one thing to learn about what other individuals on your team are doing. So, an iOS developer cross-training to doing Ruby backends, but it's a different story when you have technology teams that you're not talking with. So some of the other challenges comes down to confidence, right? As DevSecOps engineers, or whatever you want to call us, I just like the word engineer. What we want to do is ensure that the business has this assurance that product owners and everybody, they understand that the automation is there and the process is defined, and there's these coded gates that ensure that the software has this baked-in quality when it goes out to production. Releasing some of that control and having the confidence in your developers and your pipeline, that's often a bottleneck for organizations as they start adopting these technologies and this process. You want to have accuracy in that quality in the KPIs that you collect. You want to ensure that as you're gathering this information, it's accurate and people have the confidence that things are on track or things need to be remediated. It's about honesty and communication and candor. All of this requires, again, a very high level of organizational maturity. So getting to the point where your organization has this mature process in place and all this automation is working and this cultural collaboration is there, it's going to take time. So patience is always that virtue you need to have. Look at your end state, look at where you want to be in the next 1 year, 5 years, that kind of thing, because technology is going to change, processes are going to change and evolve, and eventually you're going to have this well-oiled machine that you're very confident is going to deliver this quality and secure product. So it's about having secure software sooner. And finally, to wrap up the road ahead, for me, it's going to be migrating about 1,500 applications that are agile and just traditional built applications, passing things over the fence from development to QA and from QA into operations. These kind of things, we're putting these applications into more of a defined and automated process. And that's going to be a challenge. Implementing security controls into all these pipelines. I've definitely seen some scalability issues, places where our static code analysis tools are not failing, but they're getting clogged up and the queues are backing up. Again, that's that security drag, which is very important to monitor. We want to make sure that we're not doing that when we're scanning all 1,500 of those applications. And then we want to continue to evolve and improve and really learn from the processes that we're implementing, the results of the tools and the performance of the tools we have. And we want to learn about our culture, and we want to understand what makes a team, or what makes an organization an organization. And that's, I think, at the end of the day, again, secure software sooner, and everybody benefits from that in the industry. So with that, thank you very much. And if you have any questions, don't hesitate to send a tweet to me at D Schleen or direct message, and I'll definitely answer that. If there's any questions, appreciate you reaching out to me. And Taylor, back to you.
Thank you so much, DJ. That was awesome. And yes, again, we'll be posting this on the DevOps Institute Continuous Learning Community Slack channel. And if you have any questions, you could respond through the Slack channel, and we'll relay your questions to DJ. Again, you could reach out to DJ directly on Twitter, D Schleen, and then DJ Schleen on LinkedIn. DJ will be at DevOps Connect in Singapore, co-speaking with Mark Miller, RSA in Singapore. He'll be at DevSecOps Days in Thailand, DevSecOps Leadership Forum in Melbourne, Australia. So he'll be around, and thank you so much. That was awesome. We loved hearing your DJ-isms and your thoughts, and that was an awesome deck. Thank you so much.
No worries. Thank you.
All right.